So let us continue with the next segment, BC. For BC, we will be cutting this here, and I'll just consider this upper portion. And we have this segment, BC. So let's draw the figure. So for the figure, it's kind of like this. And this one. So this is for the triangle, and this is the whole 25 kilonewton, because this is now 2.5 meter. So do not forget, this is point A and this is point B. Now you have this P force here, and also the resultant, which is 31.25. This time, at the point of cutting here, this is M, and this is the direction towards point B. This is a distance X. So with that, we are going to create now the moment equation at the point of cutting here. So summation of moment at the point of cutting equal to 0, clockwise positive, counterclockwise negative. You have negative M, and then you have minus P times 2.5 minus 31.25 times 2/3 of 2.5 equal to 0. So no horizontal force. So what we're gonna do is transpose M to the other side. It's now M, and that's negative how? Pila man ni siyang 31.25. So 31.25 times 2 times 2.5 divided by 3. It's 50 point, or 625 over 12. So 625 over 12 minus 2.5p. And the partial derivative with respect to p is negative 2.5. So the final product of the two terms is now negative 625 over 12 minus 2.5 p times negative 2.5, or we can just cancel that out, the negative. Also, we can set this to 0, so we can transform that into a positive product. So this is 625 times 2.5 divided by 12. It's 3125 over 24. 3125 over 24. That's segment BC. Let us proceed to segment CD. So for segment CD, let's just cut that here and consider that portion. So segment CD. For segment CD, it's going to be like this one. And then we have this to be 50, and we have this to be dV. Anyway, dV will just be cancelled out, so hindi na ako siya emphasize. And then you have MD here, and we have A moment m, and this is the direction since that is the consideration sa section, and that is point x. Summation of moment at the point of cutting equal to 0. You will have m equal to 50 times x minus md, where md is 252.083. So that's 50x minus 252.083 minus 2.5p, and the partial derivative of m with respect to p is negative 2.5. So now the product of the two is 50x minus 252.083 times 2.5. So we can now create the vertical displacement at point A to be downward, and that is equal to the integral, or the 1/2 of the 1 over EI of the integral, the moment times the partial derivative of m with respect to p dx, and this is from AB, then plus, by the way, AB measures 2.5. This is 2.0 to 2.5, and then let's copy this. The next one is for segment BC. This is from 0 to 2, and the next one is from CD, which is from 0 to what's the measurement? 0 to 4. Okay, in that case, we can now get the 1 over EI of the integral from 0 to 2.5 of AB. This is our AB. And this is from dx. Then plus the integral from 0 to 2. This is here. Dx plus the integral from 0 to 4, and here dx. So let's get now the 1 over EI of the first integral. That's 31.25 x plus 200 and negative 252. So I can rewrite that as negative 52.083, and then minus 5 over 3x cubed times x minus 2.5 from 0 to 2.5. This is 89.517 plus integral of 3125 over 24 from 0 to 2 to 60.417 to 60.417. plus the third one. For the third one, it's the integral of 50x minus 252.083 times 2.5, and the limit is from 0 to 4. It's negative 1520. So this is negative 1520 1520.83. So the deflection at A is equal to 1 over EI is not positive, but rather, no, I almost forgot that this must be negative. No? Okay, negative 2.5 muna siya. So here, that's negative. So let me repeat. That's 50x minus 252.083 times negative 2.5 from 0 to 4. 1520. So minus the negative. So from here, we can now add the 3, that's 89.517 plus 260.41, 260.417 plus 1520.83. So the answer here is 1870.764 kilonewtons cubic meter. And we assume that the deflection should be downward, which is somehow correct because it is at the free end. So it should move downward because of the loading sa triangle. And this is our vertical displacement of point A. There.